Okay, I'm recording our session now, the screen and the audio, and then we can get started with you know, the basic pinout. And it's great that Dimitri joined. Dimitri, if I say something wrong, please please do interrupt me. But yeah, let's see. I wanted to start with where's the picture? This picture right here. You guys can see it. The board. Oh no, I'm not screen sharing yet. All right, let me screen share.
I just made the mistake of trying to join on my desktop as well. It booted me off. Okay, yeah. I can see it.
All right. Hey, come on, give me. All right. As you can see, I have a big mouse. For some reason, it's. I just want to have my mouse cursor, not this thing. No. All right. Well, we'll just have to do with the magnifying glass instead of a pointer. Yeah. So here we have the board, and there's one key difference comparing this to the OpenBCI Cyton. And there's a few pins that we need to sort of understand. So on the OpenBCI Cyton, you know, there's the channels, and then there's the SRB2 and the bias pins, right? And so how do we compare that to what the pinout that we have on the FreeEEG32? The bias, even though it works slightly different, should be compared to VCM. VCM stands for voltage common mode. The bias on the OpenBCI is basically like an artificial ground, because you're connecting your brain, your head, to this circuit board, and so your brain is now part of this circuit. And both these devices, your brain or your scalp and the circuit board, they need to have some kind of relationship to each other in terms of their voltage potential. Now, in other systems, not OpenBCI, but you know, if you have like an the biosemi, which is the gold standard of academic EEG stuff, and that is a $30,000 machine. There you actually physically ground the person and the machine. So you connect both the machine and the person physically with a copper wire to the ground pin on the wall outlet. This is a battery-driven system, battery-operated system, which has many advantages. But that being the case, we do not want to ground the actual device, because you know it's a battery-operated system. So the VCM puts out a voltage. In this case of the FreeEEG32, it is halfway between 0 volt and 3.3 volt. The board itself operates on 3.3 volts. So VCM puts out 1.67 volts. And you connect that to your brain. And if you make your own headset, it is advisable to put that in a very central location. For example, standard neurofeedback headsets have it just below FPZ position. FPZ is on the on the, like in the middle, slightly high up on the forehead. And in other positions, other headsets will have it like all the way on the top of the head. OpenBCI actually connects it to one of the earlobes, which I don't agree with. So if you're connecting, if you're making your own headset or connecting like another existing headset, I would advise putting VCM on FPZ. If FPZ is not there, then maybe on FZ, sorry, on CZ. And CZ, you could put it on an earlobe, on one of the earlobes, but if you do that, then you cannot make linked ears anymore, and I'll get into linked ears in a moment. Another thing to consider is VCM or bias. When I don't connect it at all, I don't see a big difference whether it's connected or not. So you definitely want to have it, and it reduces noise. But if there is noise which is reduced by VCM, then I would actually in the first place advise you, strongly urge you to find a place with less noise. Because the noise that is there is environmental noise. So VCM or bias reduces and is there to mitigate environmental noise. But your first mission really should be to not have environmental noise. And environmental noise mostly comes from light bulbs, in particular like high efficiency light bulbs, from power adapters. Power adapters are terrible, so you definitely want to keep a big distance, several meters away from power adapters. The best place in a house is usually like in the middle of the living room to measure EEG. If you're sitting at your desk, you cannot do anything serious in terms of recording EEG, because on your desk you have all your power adapters of your laptop and your computer, and you might think it's a wooden desk and it doesn't conduct. Somehow it does. So you want to sit far away, and you want to run your laptop on the battery, not on the power adapter. If you follow all of those things, then you should already be very noise free, and then the VCM should not be making a big difference. In fact, it shouldn't make a difference at all. So that there's a few things there to consider about VCM or bias. Is that kind of clear what to do with that one?
I think it is for me.
All right. And you know, if you, for example, like I have a 2-channel headset that I make. And on the forehead, there are two, it measures FP1 and FP2. And then it has a third node in the middle, and that is VCM in this case. Then the next comparison with OpenBCI and how to connect. On OpenBCI, the SRB2 pin goes to one of the earlobes. And then that's it. And then you just have all of the positive terminals for every channel goes to one position on the head where you want to measure. It's different here. We don't have a comparison to the SRB2 pin. Instead, every individual channel has both a positive and a negative terminal.
Okay.
And
so it's full bipolar.
Sorry?
Oh, it's full bipolar setup.
Yeah. So yeah, so what you can actually do here, you can make, if you wanted to, you could make every single electrode a bipolar setup. Which with SRB2 you cannot. With SRB2 you have one, you know, I mean, you could put the SRB2 on a different location, but you can do that only with, you know, all of the channels will then have their negative pin on that location. The way to consider the difference between this system and the SRB2, every single channel on this board has 2 pins. There's a negative and a terminal, and a positive and a negative pin. The positive pin goes on the location where you want to measure, and then you have to place the negative pin elsewhere. And consider these 32 channels that we have. Each of them is like a voltage meter, like a multimeter where you measure the power of a battery, right? Except it does it 512 times per second with 200 nanovolt precision. But when you measure the power of a battery, you have a red wire and a black wire. The red one is the positive one that goes to the positive terminal, in this case somewhere on the head, And then to complete the circuit, we need to also connect the black wire, the negative terminal. By default, you want to place that on a place on the head where there is no brain activity. So the earlobes are really very suitable for this. Sometimes, like in the case of bipolar measurements, bipolar referring not to the bipolar mental health condition, but to a bipolar where you have the one of the poles on one place and the other pole in another place. That's typically only done, I think, in terms to reduce noise when there's like heartbeat and that kind of stuff present in the earlobe. But the negative terminal usually goes on the earlobe, and usually, most commonly, people use a system which is called linked ears. And suppose we have 32 channels distributed on the head according to the 1020 system. And then linked ears. Linked ears means that all of the negative terminals of all of the channels are connected together. And then 2 wires from there go to both the left and the right earlobe. And so the ears are linked. That's why it's called linked ears. Here we have the option whether we want to connect all those negative terminals of all the channels together or not. If you do it, you have to do it physically with a wire. The Open BCI board has the option of doing that from a single pin out, which is already on the board, and that pin is called SRB2. So SRB2 is a collection of all of the negative terminals of the 8 channels on the Cyton board. And here we don't have that, but you can make it yourself by connecting all of the negative terminals, or what you can do is you can take a number of negative terminals, connect them, and keep some channels available for different montages. And the locations of the channels, this image gives us a good idea that we just need a minor little bit of extra explanation. Over here, yeah, yes,
I'm
please.
just looking at the GPT page, but I don't know if that's just me. Discord seems to be being a bit weird, but just in case.
Sorry, you're looking at what?
So all I can see on your screen, it says ChatGPT.
Oh, really?
ChatGPT. I don't know if that's me because Discord's been being weird for a bit.
Oh, so I've been sharing the wrong screen.
Sorry.
No, thank you for clarifying that. Okay, I gotta share a different one.
Yeah, I saw it earlier. It was. I get so frustrated with all these different meeting applications doing different things.
Change window there. All right, now I see it.
Oh, you looked at that.
I think when I dragged it out of this, it must have defaulted back to ChatGPT. Yeah. All right, so thanks for notifying me on that. All right. Yeah, this would have been a pretty stupid explanation otherwise. All right, so just to clarify, here's the VCM pin that we have just discussed at length, which I think is clear now. So these blocks of 10 by 20 connectors, they're the same everywhere. So VCM is here. If you turn this thing clockwise, this will be VCM, and this will be VCM, and this will be VCM. So it's not mirrored. It's just turned 90 degrees every time. That's how this works. So VCM is over here, and VCM is over here, and here, and here. VCM is already internally connected on this whole board. So if you connect one of these VCMs, you're done. You don't have to also connect this and this and this. Internally on the board, all the VCMs of all the 4 ADCs are connected. So that's an important little thing to take note of. All right, then here we have the first 8 channels, and I just discussed about the positive and the negative terminal. The outer pins are the positive terminals, right? So here, right here, it says 1, 2, 3, 4, and then here 5, 6, 7, 8. So it's a little bit counterintuitive. It starts in the middle with 1, 2, 3, 4, and then it starts again in the middle with 5, 6, 7, 8. This right here is the positive terminal of the first channel that comes out of the data stream. And you can label it however you want. That depends on the on whatever software you use. But what the first channel that comes out of the data stream and that appears on your list of channels is going to be this channel, and then number 2, and then number 3, and number 4, 5, 6, 7, 8. And the corresponding negative terminal of channel 1 is right here. So here's the plus, and here's the minus pin of channel 1. And here's the plus of channel 2, and here's the minus and negative of channel 2, etc. Right? And so this is the first ADC with channels 1 to 8, and then here we have 9 to 16, and that means that right here this is channel 9, 10, 11, 12, and then again back to the middle, 13, 14, 15, and 16. Is that clear?
Sorry. It's the one that's closer to the edge is for negative, and the one that's closer to the center of the board is positive.
Yeah, that's correct. Yeah, and so in this image here it says 9 to 16. So there are 8 channels here, and the first 8 are here, and here are the next 8. And the way the numbering works, like this one right here, like so we have in total 10 holes here. The outer holes are VCM and the power supply for other functions, for active electrode, for example. So the inner 8 holes here are the actual 8 channels that we have. And it starts from the center left, or center right, depending from what direction you're looking at. But so this one right here is the first channel of this ADC. So in this case, it's the second ADC, so channels 9 to 16. So this here is channel 9, and then this is channel 10, channel 11, and channel 12. And then on this side, channel 13, channel 14, channel 15, and channel 16. And these are, again, the positive terminals, and then more towards the center of the board are the negative terminals for those matching channels. And then we turn to this side. Here we have channel 17 to 24. So again here, this would be 17, 18, 19, 20, 21, 22, 23, and 24. And here again, and again, because this is clockwise, so here we have 25, 26, 27, 28, and then 29, 30, 31, and 32. So they're all exactly the same if you turn it 90 degree every time. So there's no mirroring. This is just turning the system 90 degrees every time for every ADC. Is that also? I think that this describes all of the channels, right?
Yeah, I think so. If people forget, it's easy. You can see that the chip's been rotated 90 degrees. So when I was looking at it, I thought, well, you can see it's been, rotated and flipped. So that would be how they must map.
Exactly. It's just a rotation. It's not a mirror. It's a rotation. Then also on every block of pinouts for every ADC, there is a power supply. If you wanted to use active electrodes or do something else, and that is VDD and GND. VDD is the plus, and that gives 3.3 volts, and that every time is on this position, and that rotates also. So here, and here, and here, and here, And then the ground, the negative terminal for that is here, and here, and here, and here. I don't know what we do with AREF. I haven't touched it. If you make a headset, I don't think that's what you use, but you do use this when you interconnect multiple boards. But for headsets, AREF is not used, but for other stuff, AREF is used. So I'm going to stay away from AREF because this is all I know about AREF. I'm not a programmer, I'm not an electronics guy, I'm more of like the headset kind of guy. Also very important to know is you have two micro USB ports. One of them only supplies the board with power and the other one only streams data. And obviously you need both. So here's the power on this side of the board. And I highly recommend using a power bank, because if you use, like the USB power out from your laptop, then the whole purpose of having two power ports is defeated. The reason we have separated power is to have a very low noise system. And on the back side of the board there's actually a DC to DC transformer to completely isolate any noise that might come from the power cable. So it's this split system of two USB cables. Although it's a nuisance of having two USB cables, this is sort of one of the things that makes this a quality system, because you have a complete separation of noisy power and so you're able. Sorry, let me say that differently. You have the ability here to power your board with a complete noise-free power source, which is a power bank, and then on your data cable there's no power supply, so the noise from that cable doesn't deliver, doesn't enter the board. And so on the other side of the board, there's the other micro USB cable here, which is only data. So that one you plug into your laptop or into your Raspberry Pi or whatever you do. And of course the board doesn't function without power, so you need both of them. Then if you wanted to, there is an isolated UART port here. So this big thing here, this component is another isolator, and that isolates the UART port. I believe though that this needs to be powered, and maybe this thing is 3.3 volt capable, but I myself, so I use these ports here, and this thing needs to be powered with 5 volts, and so I actually have an additional little wire that I solder from here from the power supply, which is 5 volts, to power this system here, because this here is isolated from the rest of the board. But only do stuff here if you really know what you're doing. If you're just connecting a headset, then now all the information is there. On this side, A2, A4 and A6, as well as the 5 volt and the ground, are needed for flashing the board. But all the boards that were sent out are already flashed and already have firmware on them. And there is a video, not a video, there's a tutorial on GitHub explaining how to do the flashing of these, using these pins. But one thing that is far outside of my knowledge base. I know how to do it step by step, but I don't know how to talk more about these things. But anyway, for the moment, no one should be needing to do that because everyone's board is already flashed, pre-flashed. So yeah, that is the way to, all the ways to connect a headset. Where to find the pins, and again, if you want to make a linked ears type of connection, then you usually take all of the negative pins of the channels and interconnect them, and then using 2 ear clips, one to the left ear, one to the right ear, then you would be having a linked ear setup, and then all the other channels, however many you use, they go to the different positions. The plus terminals, they go to a position on the head, 19, you know, the 1020 system, or whatever you do. Then there was the question of how to interconnect multiple boards, and that will need some soldering. And I'm going to show a different picture. Let me stop it. Just a sec, I need to upload 2 pictures that I took earlier. All right. Share my screen once again. All right. Can you see this one?
Yeah.
All right. So if you want to interconnect multiple boards, you need to do two things. One is you need to connect, you need to solder header pins, which on one side are male and on the other side are female. I don't have a DigiKey link to that right now. Maybe Dimitri, if you're still listening, you can find on DigiKey a like a 2x1 header pin that interconnects the boards. And of those, you need in total, what, 11? Yeah, you need 11 of those. Or I would recommend soldering all 11 of them. But before you do that, there are 4 0 ohm resistors that need to be removed from the board. And just so everyone knows what a 0 ohm resistor means, in order to operate this board by itself, there need to be 4 0 ohms resistors, and I'll show you the position. One is right over here, and what it does is these 2 pins here, when you interconnect multiple boards, these 2 positions and many other positions, with a pin they go directly to the same pins of the other boards. But if you're not using the system in multiples, but just a single system, then 4 of those positions, these 2 pins need to be connected together. They need to be connected with a 0 ohm resistor. And that little resistor is here. And what this resistor does, it's called a 0 ohm, so it has no resistance. It's basically a wire. And that connects these 2 pads directly. So this little one here needs to be removed. And there's another one over here, which connects these 2 pins, interconnects these 2 positions. There's another one over here, which interconnects these 2 positions. And then there's a 0 ohm resistor here, which connects these 2 positions. So those 4 0 ohm resistors have to be desoldered. And then on, I think you only need on those 4 positions, but while you're at it, I would say just solder all of the positions that there are. There are, if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 locations where there are 2 pin headers, like a position for 2 pin headers. And in each of those positions, you want to solder a pin header that on one side has female and on the other side has the long pins, the male pins. And then you solder them in the same orientation on every board. And then like a little, they piggyback on top of each other. And Dimitri, correct me if I'm wrong, but I believe that the resistors should be removed on every single board. like within the system of interconnected boards, there's not a single board that needs to have these, right? Like they need to be removed on every single board. Is that correct? Can you confirm?
Yes, need to remove all these 0 ohm resistors.
Yeah, on every board within the system of.
It's okay if will be removed on all boards, but on one board, these 4 connectors or resistor need to be soldered or need to be placed the jumpers.
If there are jumpers on one of the boards, then why is there a need? Then why is there a need to remove them on the other boards? Because then it's all connected anyway.
These jumpers, they need to be connected. So you said before that need all them to be same, but only 7 of them without 0 ohm resistors need to be interconnected between boards. Only them.
Yeah, I see what you mean. Like on the other on the other systems, you don't place jumpers. But I'm thinking if, regardless of the function, whether it's a single board or multiple boards. So on a single board we have the 0 ohms, and on multiple boards there might be the jumpers. But if we just leave the 0 ohm, actually the 0 ohm resistors do not have to be removed at all if there's jumpers anyway on those 4 positions.
If you cannot remove them on only one board. It will become main board which provides a clock. These jumpers or 0 ohm resistors, 4 of them, they modulating clock and providing clock. And if you remove them and solder, then it disables clock on this board.
Yeah.
Because several clocks give you big interference and it's not EEG type noise.
Yeah.
Not filterable.
Yeah.
So only one board can provide clock, and this 0 ohm resistors or jumpers from 4 places enables clock.
Yeah, but I'm just thinking because then all the boards are connected, but then to my understanding, it doesn't matter where the 0 ohm resistor is because it will be interconnected.
Only these 4 not interconnected.
Yeah.
Only other 7 without them, without these 4, they interconnected. 7 interconnected, and these 4 only connected on one board and not all other.
Okay, I see. Okay. Yeah, so out of the 11 double pin locations, we interconnect the 7 that do not have the 0 ohm resistors.
Yes.
Okay, so then what I said earlier of placing the header pins on just on all of them is not correct. It should only be on the 7 locations that do not have the 0 ohm resistors.
Yes.
Okay. Good. Great. So I'll go back to the.
And another correction, maybe I recognized not correctly, but inside board there are minuses, and outside board is pluses.
Yeah, yeah.
This is different than in Cython. I tried to copy Cython, but I forgot about it while I developed it, because it's better. It's this way how it's okay to connect on this ADC. This ADC provides pins from this chip, so it was unable to connect different way. So
yeah. Okay, so
another minuses inside board, pluses outside.
Yeah.
And
So
this INREF minus is for interconnection of all minuses on all boards. So you can connect all minuses to this IN minus, and it automatically will interconnect within all board.
okay.
Several as VCM or ground.
So that would then be, if you do that, it would take the function of the SRB2, which is on Cython.
Yes.
But you have to physically do it. You have to first take a wire from all the minuses to the INREF.
Okay, so if I jump all the negatives I want with a ref, then the a ref pin on all 4 amps are going to be linked together, so I can then jump on a different set of channels and get the same.
Yes, it will interconnect on any of 20 on 2 connectors. INRFs are interconnected, and they interconnected also when you stacking boards. VCM interconnecting, INRF interconnecting, ground interconnecting.
So I just want to clarify what we had discussed earlier with the locations of the positive and the negative terminals. That remains the same as I had explained it, but the difference is on Cython it is opposite. Like this here is the positive terminal of channel 1, and this is the negative terminal of channel 1. And in Cython that is different, but as we had discussed it here earlier, that is still how it is.
So idea was to copy Cython, but this ADC chip providing channels this way. So I'm not making vias in board to make different. I made without so to provide output of ADC directly with minimal biases or anything that can create noise.
I think
this is why this numbering looks so.
Yeah, the numbering is yeah, that comes out of the ADC that way. But I think instead of copying on Cython, you've improved on Cython. So of course things will be different.
I think also the typical thing is you use all the bottom ones. So you well, at least what I've seen, you plug in SRB1 as your ground lead in essence, and then you put your signal into the bottom, which are on the negative. Whereas here, right, the positives are on the outside, which I've got the pre-soldered ones, so they're on the bottom. So I'm still plugging my signal into the bottom, except it's going into positive pin rather than negative pin. That makes sense. I'm wiring it the same way, but I'm actually putting it into the plot. Your red lead on your multimeter, which makes more sense to me. Unless I've got that the wrong way around again, but I can check my notes.
I didn't fully get that part. Here you have the angled pins. So yeah, that means that the bottom pin is the pin closer to the board is the positive one, and the pin further away from the board is a -1. For every
Yeah, so
channel.
the inside pin is negative and the outside pin is positive, right? But that's flipped on the Cyton, except when you're using SRB1, you plug your signal into the negative for reasons I don't fully understand. I presume it's just the way the amp's designed. So
Oh, is that so?
it makes more sense that you're wiring it, you're physically putting it into the same bottom connectors. But yeah, it took me a while to get my head around that. Like, I asked a few places, and they didn't. It's kind of similar like discussion we're having now is what we didn't really provide. It's just here's how to put your ultra cortex in, which is great if you've got one, but not if you're doing it on the cheap.
Okay, well, it's been a long time since I worked with OpenBCI. Fortunately, it's been a long time. So, oh no, I didn't remember that part. Yeah. So like how exactly that works with SRB2, I don't know, but yeah, the thing is here. Instead of having that sort of that thing all collected, we have to do that physically, pin by pin here, with the negative pins, channel by channel. The interconnection of the negative terminals.
More hardware, but I think is conceptually easier, to be honest. Than
Sorry.
You need more wires, but I think it's conceptually easier, to be honest. This is a simpler setup than I was thinking it was because I'm used to the site.
Yeah, you need more wires, but you have more control in that sense also.
Yeah.
Because if you wanted to, you could make, and I think this is possible with Cyton, I'm not sure, but here, if you wanted to make every individual channel having a completely different montage, having its negative terminal on a different location, you could do that. And it also means that if you wanted to, you could use every channel for a completely different function. Like, you could use one for
EMG or something.
EMG and EKG and whatever, because every channel has a full pin out. And so I don't fully understand yet what Dimitri was explaining about the ARF, where, to my understanding, Dimitri, like, we can connect all of the negative pins from one ARF. So sorry, all the negative terminals from one ADC connected to one ARF, and then that would be the common reference pin for those 8 channels.
Yes.
Okay, and so you could do that 4 times. So you could basically create 4 different groups for every ADC, its own group that way.
Yes, and also between boards.
Yeah, and between boards. If you connect that pin, which is yeah, here. Great.
And about UART isolator and SPI isolator, this on the other side. 5 volts, if provide 5 volts, then all data also will be 5 volts. And if you provide 3 volts, then all data will be 3 volts.
Yeah.
Because if you connect 3 volts, 3.3 volts microcontroller and provide 5 volts, then you will destroy your microcontroller outside this when using this isolator. So you need provide such volts which you need for your data.
Yeah,
3 for 3 volts, 5 for 5 volts.
Yeah, so this pin here can be 3 or 5 volts depending. Like
3 or 5.
Exactly. So this pin here
Depending
is
on your
tolerant.
MMQ.
Exactly. But you're connecting this to some other device, and depending on the needs of that device, you connect either 3.3 or 5. Like in my case, I'm using a 5 volt application here, and I'm powering it. I just soldered a wire from the power supply here, and that wire goes here to 3.3 and to ground. and then I have my optical components here, which require 5 volts.
But if your optical components have noise, it will be on your power.
Yeah.
It's not okay.
Yeah, yeah, but the optical components is, it sounds very fancy when I say optical components. It's just an LED. So LED and one capacitor. One capacitor is also there.
It can provide noise. It's frequency, some frequency.
Yeah, that is true. But that is on the power, and it's a small. I've not seen any difference in I've tested to see the noise level with and without the optical, and there's no noticeable difference in peak to peak or RMS. It's the same.
Yes, this power filter, power isolator, it's also making some filtering. So maybe can make some filtering.
Well, I connected it before before that yeah that's why because I connected it right here at the USB cable.
But if you connect it to 5 volts where debugger, it's not okay. Will be so all noise will be inside board.
Yeah, but from the debugger, this is, I think, this is not. This is a 5. This will be a 5 volt supply. Like 5 volt is not. This will receive 5 volt to power.
Yes, this 5 volts is 5 volts after it filtered by transformer. It's inside.
Oh, okay. Okay. So it is actually giving power. I thought it was only to power the board when flashing it.
So nothing noisy can be on this power.
Yeah.
Connected.
Yeah.
All noisy after outside of this is isolators and transformers.
Yeah.
So that 5 volt can be used as a low noise, high quality supply if anyone wanted to connect in something else, whatever reason.
I would say
sure.
I would so
about which.
Yeah, so he's suggesting that if we use a 5 volt low noise external application, we could use this. But I would not recommend using this. We only use this when we flash the board, because when we flash the board, we have to power the system, and then we do it using these pins, and not the USB port. But then
that's an input, is it? It's not a. I thought you were saying that that's shared with the DC-DC transformer. So that 5 volt is an input for flashing.
Yeah, but we don't use it while we're measuring EEG.
It can be removed, this 5 and that 3 volts. Maybe it's not a good idea to wire them out. Better power it anyway via isolator and connect from debugger only ground and other 3 debug. As on all other dev boards, you're not connecting power when you're debugging. You only connected ground and something from debugger. Power always better provide from output, from isolator, from transformer. So inside this power, only to check it better. Because if you have some problem with this power, then you can destroy board. Because 5 volts also can destroy something. 3 volts. You can accidentally provide some 12 volts, as I always doing. If you have 9 volts, will destroy board. But in isolator, you will just destroy isolator, or not destroy it. It have more protection. So better not touch this ground, this debug pins when you're not flashing.
Yeah, this is really just for flashing applications.
And for general debug.
Yeah, yeah.
I had a quick question. It's slightly tangential, but that's all right.
Yeah, I think that's all right.
I was just wondering on the linked tier setup. So I've noticed when I've been using the Cyton so far that obviously the side, I guess the opposite side from the one I've put on the SRB has my heartbeat in it more. I think if not the other way around. One side of my head features more of a heartbeat than the one due to the way I've referenced it. If you link the ears up, does that take care of that better? Do you find less of an ECG artifact in things?
Oh, I don't know about that.
Okay.
Yeah, I don't know. I just know that the OpenBCI way of doing it with, you know, like basically the bias on one ear and the and all the reference on one other ear, that strikes me as very odd, because you know, then you're referencing your whole head to one side of the head, right? So instead of even, like I don't quite understand the reasoning behind it.
I've been following it sort of for lays and just keeping it simple because I'd already, I got the ear clip electrodes so I could use two of them. But I equally was like the symmetry, the lack of symmetry sort of unnerves me a bit. I think I tried one on my neck at some point to see, but then I was definitely getting much more of a heartbeat in it as it was, probably physically moving there. So it was like, that's not going to work.
When you put it in your neck, there's like the earlobes are really fantastic for this, because the earlobes, like, there's no brains in your earlobe, right? So that's what we want. We don't want any EEG to be present, and there's no muscles in your earlobe, and there's not even any big arteries in your earlobe. So like it's sort of, it seems to be its only function, that we have an earlobe, that we can do EEG with it. Like, it's such a convenience that we have it right there. But if you put it here on, like, what is I think called position A1, like behind the ear, you have a much higher odds of getting a strong heartbeat in there. So the earlobe is more suitable than here. But it also depends on the person. Some people don't have a strong heartbeat in their ear, and some people do. So,
Yeah, I think I've seen it, but myself.
Yeah, so you might be one of those people who's got like a strong heartbeat in his ear, and like that's the reason why neurofeedback, when that's the case, people come up with a bipolar montage to place the negative terminal somewhere else on the head, where there's
I made. Sorry.
Yeah, no, go ahead. I mean, yeah.
I was just going to say, I may try FPZ because I've been doing C3, C4 quite a bit. So I was like, I don't need an extra thing getting in the way, but also I'm not sure how great it would be for biasing there. But I'm not bothering with the frontal lobes much because I don't think they're much use for me. So FPZ would probably be a good place to use for the V common, which is also makes more sense in terms of naming because that's what it is in the amplifier. So
yeah, like in the all of the standard, like, common neurofeedback amplifiers and headsets, they all have the common, like right here on FPZ. So not on FZ, which is kind of like here, but more on FPZ, which is basically on the hairline, if the hairline is
prefrontal, isn't it? It would make more sense to call it PFZ, I think, right? But I call it FP.
Yeah. That's one thing which is a little inconsistency. The main inconsistency there is, like, when you in Python, when you have to label your channels, it has to be FP capitals and then Z small letter, and FP capital, but like CZ and FZ and PZ, it is F capital or P capital or C capital, but then the Z has to be small. And like who came up with all of that and why it drives me nuts. So capitalizations in the channel numbers when you're using MNE or another Python package to crunch your data, capitalization of the Z when and when not is critical. Little thing to know, to be aware of. I wanted to add to that Biosemi. They use the driven right leg method, which I cannot fully explain how and what they do, but they have the components for that, which is comparable to our VCM or to bias. They have that in divided over 2 electrodes, like it's more of an active system, on either side of PZ. So again, a slightly different system. Yeah. In other words, there's many ways of doing it, but basically, most conventional, it will be somewhere on the central line, on the Z line.
Mm.
And it makes sense because if you're both measuring things on the right and the left side of the brain, you do want to, whatever influence you're creating, you want that to be equal everywhere you do it. So you want to be somewhere central, and the same thing with the referencing with the minus terminals. I would be very uncomfortable to do that only on one side of the head. Like in my headsets, which are a little bit uncommon. My application, I should say, the headsets I'll be sending out will be linked ears. But for my applications, I don't use linked ears. I reference everything on the left side of the head with the left earlobe, and everything on the right side of the head to the right earlobe. And
Yeah, I've heard that as well.
And FZ and PZ I divide, like one I put on the left side and the other one on the right side. And there is a debate whether linked ears is a natural thing, because you're connecting you're connecting the left and right side of the head with a wire, which is in its natural state is not the case. So there are people who oppose it, who oppose linked ears, who would say, like, I don't know what they call it, but I'll call it unlinked ears, right? Yeah, just for the argument being, it's not how it is by naturally, and we want to measure the head in its most natural state. That's all I've got. That's all I've got, unless you have any questions. Or anyone else has questions.
That's probably, I mean, that was really helpful. Thanks. There's a lot of really good info. So, I really appreciate it, Dimitri, as well, for taking the time. That's great. I'm going away for a bit, but I'm really excited to get started using this now. I'm gonna have to sort of check and get data off it, and then put it away and come back in 3 weeks' time. But I'm raring to go.
Oh, that's terrible. Yeah, no. What software are you using for your project?
Mostly Neuromore at the moment, sort of being, I think, just the most viable thing out there. And I sort of, essentially, some it's hacky, whatever. The actual sort of feedback element, I got a couple of games, but I'm mostly just using some custom code, watching TV, so it's just hooking into my compositor. I'll get all that tidied up and pushed at some point, and then I think, yeah, Neuromore seems pretty decent as far as what I can see. Like, it's got quite a lot compared to some of the packages out there. It's all in MATLAB or whatever. There's quite a lot in there. I think there's some basic usability stuff that needs improving, but that's what pull requests are for. So hopefully, if I sort of start seeing more effects in myself to the point I'm sort of training every day and reliably seeing improvements, and the next thing is to start sort of tightening some stuff up and expanding it and getting some things pushed up, and then hopefully for someone in the future it can be a bit less sort of hacking it together and more there's a series of things that can be downloaded and some instructions and stuff like that. But Yeah, Neuramores is sort of short for implementing the protocols at least.
Is Neuromore, what is the latest version? Have they released a new release since 1.6?
I'd have to check. I built it from source. It's a bit of a pain to debug. It's like kept working out it wasn't real time and killing itself. And I was like, no, it's still stepping through.
I'm really interested to if you've built it from source, because the release that they have uses an older version of BrainFlow, and I'm very interested in having a new release from like basically built from source, but then with a newer version of BrainFlow, because they use a very old version of BrainFlow.
So they also, I mean, it's not. I think I've seen other projects do this. They sort of fork a whole of Qt and then build it themselves, which might make sense from a licensing point of view, a bit like Solaris does stuff. But it's 1.7.1 2 weeks ago. I've just seen because it's FreeEEG32 is listed, but I was just trying to plug it in, only having had the board since Saturday, trying to plug it in, and it just still says board not connected. I mean, things like that. Like I have to sort of redesign the file slightly just to change boards, and it would be a lot more convenient just to pull it out of the protocol and keep it high level. So I think there's a couple of niggles like that could really go a long way in making it much more usable. But fair dues, they've released it for free at least. I can't complain. But yeah, I'm just seeing this 1.7.1 just come out recently.
I have to check in their 1.6 because they used an older version of BrainFlow. It did have support for FreeEEG32, but it didn't have at that. So I use an optical connection through the UART, and in the older version of BrainFlow there was a bug where it didn't work. Well, not a bug, it just didn't work yet. The optical didn't work yet, but now in a more recent BrainFlow, already since over a year it does work. Last year and a half it has worked, but in 1.6 they just had an older version of BrainFlow than that. So
if you haven't built it from source, I've got a sort of Docker-based recipe. So just hit me up in a DM or something, and it may not be for a while, but I can get you even if it's not in the latest build they've got, I can try modifying it to just pull a newer BrainFlow and send you the binaries. Oh, great. So let me know if you want me to try that.
Oh, definitely, yes, please. I mean, well, first I'll try the new thing, but like for me, all this compiling and that all of that is not my forte.
So. Yeah, that's fair. I'll happily do that. Because I'm not with electronics. Like I've done the basics when I was 10 or whatever, and physics degree and no bits of it. But this sort of stuff is beyond. I'm not going to start trying to unsolder those resistors because I'll just burn something. So I'm just going to stay away from that for now.
I'm just seeing a question from Chlorophylla. Because your microphone doesn't work. Question, yeah, and please do continue to chat all your questions that you have. Hermesa, great, okay. Oh, Hermesa, we emailed some time ago, I remember, I think. I think, Dimitri, a single power bank should be fine, right? I mean, as long as, obviously, the power bank is going to have two outputs. But the main thing, Hermesa, is the reason why we use a power bank is to have a noise-free power source, and so you don't want to use, like an extra USB port that's on your computer, because your computer does produce quite a bit of noise, yeah. If you use a power bank, the power bank then will have that cable will then have all the noise from the power bank, which is almost nothing, and it will also have the noise that comes from the FreeEEG32 board, which is even less than almost nothing. So it should be totally fine to use to use a single power bank for two boards. But then you would need a power bank that has multiple USB out ports.
So do people need a separate lead for each data stream?
Yes.
They don't.
Yeah.
They don't link up.
Yeah. Yeah, so for every board you do have, I mean, Dimitri, there are ways in OpenVibe to have it as a single, to capture it with a single API, but for every board you do need a USB cable connect. So if you know, for example, if you use 8 boards, well, then you're going to be having 8 USB cables to your computer.
Or 8 optical isolators as you using.
Yes,
optical.
yeah. I did that once. I'll share a little picture with that of that. Let's see.
Is that for noise you do it? So I wasn't entirely like using fiber optics as opposed to an electrical connection for sending the data.
Yeah, I do that for several reasons. The first is I started doing it because I needed to, my project was hyperscanning. So scanning multiple brains, each having their own headset and their own board.
Right.
And then looking for synchronicity between the brains. I had a moment, well not a moment, I had a period of 2 weeks of euphoria because I found this extreme synchronicity between 4 people. It was really phenomenal and fabulous. I mean, at first I thought it was noise, but then one of the people who was there on the project, he convinced me that it was not noise, that it was actually indeed, you know, brain activity. And it was completely synchronous. It was amazing. And then I discovered it was indeed noise, and it came from my laptop, most likely the CPU fan, and that noise traveled through the USB cables to each individual device, and so it added noise on every system. And so then I realized we cannot even have USB cables in hyperscanning. We cannot even have USB cables. So a friend of mine came up with this really cool little system of connecting an optical diode to the UART, and then with with a USB dongle with a receiver on the other side. And so now I'm capable of doing hyperscanning while all the subjects are completely isolated from each other. And then I also realized with the optical cable, there's no more noise from the PC, and it also means I can just run my PC on the power adapter. And the optical wires that I use, they can be 10 meters long. They're not glass, they're plastic, optical plastic. So they have a maximum length of 10 meters, which is long enough. It's a whole lot longer than a USB cable. And so it makes everything much more convenient for me as well, having these long cables that are plastic instead of copper. So it reduces noise tremendously. Yeah, I'm very happy with my optical cables. And I have in the past tried to have 10, when I had 11, sorry. For a little beautiful moment in time, I had 11 boards, 11 FreeEEG32 boards. And I had them all connected on my laptop with USB hubs to get to that many USB ports. And so every FreeEEG32 device had its own optical cable going to its own dongle into its USB hub into the laptop. And I looked for, you know, packet collisions or something, which USB is sensitive to that, but there was no issue, no limitation in that. So I didn't get any packet issues with any of that. So yeah, in the case of USB, in the case of optical cables, it would be that many optical cables per board. Let's see. Ermesa is asking, you want to connect the Raspberry Pi?
Question about power. The all power inside connected, interconnected inside board. Power from after diodes, power output. It's on 7 interconnectors. So providing power to one board will give it to another boards.
Oh, great. All right, so one USB power cable is enough.
But if you have not powerful power bank, which works with one board, it will be not enough for many boards. So you can connect several power banks, maybe.
Well, I think, Dimitri, since the new, well, it's not new anymore, but since the new firmware version where you clock down the microcontroller, it is not using so much power anymore. So probably any power bank, because most power banks are quite capable. I think.
Yeah. I mean, it's about anyway. One power bank, one isolator, one transformer can provide only 1 ampere
Okay.
at 5 volt. Only 1 ampere. So you can't provide more. If you have power bank which can provide 3 amperes, it will not work. You will need 3 power banks or connect one power bank to 3 ports if you need to provide more power.
Yeah, yeah. Yeah, okay. So the limitation is not so much the power of the power bank, but the throughput of the transformer.
Yes, one board no need so much. 1 ampere no need for one board. But for several boards, for 2 boards maybe okay. But it depends on firmware, as you mentioned.
Yeah, yeah, but
if you have powerful firmware on full power of this controller and not have noise with your firmware, then it can be not enough power to power multiple boards from one transformer.
yeah,
So it can be one power bank, but you need to connect it to multiple boards if you have noise. Because if you have not enough power for device, you can connect it with battery, which battery low, and it will appear noise. When you have not enough power, you will have noise.
Yeah, yeah, but fortunately with the new firmware, for everyone to know, earlier until I think Dimitri was fixed a year and a half, maybe 2 years ago by now. The earlier version of the firmware was using the microcontroller at the full 480 megahertz, and these boards would get really hot. But actually the board doesn't use all the power of the microcontroller anyway, so you downclocked it to 80 megahertz, and now it gets warm but not hot, and all that heat dissipation is not necessary anymore, and so all the power consumption has been reduced a lot by then.
Next question about about Pi.
Yeah,
Pi, Orange Pi, Raspberry Pi, Lychee Pi. Now I'm testing 2 boards with RISC-V boards. Lychee Pi. Also the open running OpenVibe. About you mentioned about your fan, which create noise.
I think it was the fan. It's the only thing I can think of.
I also have fan on my Lychee Pi. It's not okay. I think it can provide noise. Powerful motor can provide noise as powerful any. It can provide noise even not via USB. It can provide electromagnetic noise.
Yeah.
So it's electromagnetic device.
I want to look at Ermesa's next question about the Raspberry Pi to power that from a power bank.
But without fan, it can be okay if you're not using fan. But you can. But better if you have noise, try remove fan.
Yeah, and that power bank which will power the Raspberry Pi should not be shared with the FreeEEG32. So
it depends on what your appetite to noise, to no noise. If your algorithm can filter this noise, then okay. I testing some algorithm connecting to just PC with AC line enabled. So I have all AC line noise, but it's filtering with notch filter, and okay. Sometimes in daytime it's not filtering. In nighttime it's filtering. So in nighttime noise symmetrical, and it completely removed by notch filter. But in daytime, many consumption, it's not symmetrical, becomes not symmetrical AC line, altering current line. So I think it's because of unsymmetrical consumption. So how this why this isolator made? You discussed, and first I skipped later. I come later about history of how you got these devices, but how this device appear. I asked about teaching of firing. So teaching of aiming for not sure for who, but for an exoskeleton. In exoskeleton to make EEG for exoskeleton to some teaching of some action, but power should be from battery of 60 volts. It down voltage, DC, and then provided to EEG. So this is against what made these transformers? Against some 60 volt noise, not much than 60. If it's so, if it about device connected to power line, it's not okay. It's not for this. It's mobile device.
Yeah.
Still mobile. It's with isolator, but it's mobile device. OpenVibe, OpenBCI, it's mobile device without isolators. It can be connected to 60 volt battery. But this device can be connected. It has isolators for power. But for cleaner power, better connect data separate than power.
Yeah, and
But if you have clean power on Orange Pi, Raspberry Pi, Lychee Pi, and it's not creating noise depending on your application, you can connect power together. Power and data from one source. But if you have power from something like, if you have data from PC with a C line, I mean 220 volts, better power from another way.
I think Hermesa's application is academic, and in academic setting, you want to basically not compromise on noise. So I would say power the Raspberry Pi from its own power bank, and then separately the FreeEEG from a separate power bank.
Wrong. I was in some academics on medical institute of scientific medical part of this medical institute was scientific part where they tested my device, and their device was connected to AC line. There was huge noise, but they have 1 to 30 hertz filter, and they fine for
Well,
their application. So
my professor here, he told me very clearly, garbage in, garbage out. So we don't want to measure any garbage.
Yeah, I was going to say, I
yes,
think my stuff would make you shudder. I mean, I've got a massive fan on top of the server, which is plugged in and, using just the USB on there to keep it simple for now. So I might as well have a washing machine right next to me at this point.
in their environment, in this institute, medical, scientific, my device not work. They filter work for their data. I can't filter it in their environment. So my device can work clear in clean environment. But in their environment, where they filter work for their data, for their setup, for their noise, it's only work for their setup. They show me, it's okay, data, fine. I can't work in their setup. But so this depends on your filters. If you know your noise, you can make filter for your noise. But better not have this noise, not create noise.
Yeah.
They published that it turns out there's a new sort of like alpha wave at 50 hertz, but in an American study they found it at 60, which must explain why there's a difference in culture between Europeans and Americans. The brains are actually oscillating at just a slightly different frequency.
Oh, that's very interesting. Because so here's a little experiment. I would encourage everyone to try in terms of noise, like just to see how strongly noise affects you. So if I measure, if I got my headset on and I'm sitting at my desk, a little distance away from my desk, like I slide my chair back, let's say 1 meter, 2 meters. And I have my feet near the power adapters. I'm not touching the power adapters. I'm just, half a meter away with my feet from my power adapters. Then I will see a strong 50 hertz or 60 hertz, depending where I am, spike in the FFT, right? And then when I move my feet back, pull my feet towards me, move my feet back away from the power adapter, that 50 or 60 hertz spike goes down. Now, here's why that's interesting. This means that the 50 hertz noise isn't picked up, by the board. Instead, it is picked up by my body. It enters my body, and then the board measures it. Right. So
yeah, I also read some time ago that if you need is isolated on food, something isolated on floor. Isolated floor when you sit, where you stand, need to be isolation against this 50 hertz or anything.
Yeah, because we kind of take it for granted, like we think, there's no. Often we don't quite think about this influence of this electromagnetic field, but it's very measurably entering our body and having an effect, which is measurable just with this equipment. And for me, the thought of that field being there in my body all the time, everywhere I go, pretty much in the house, made me realize, like, hey, I want to control where this 50 hertz or 60 hertz is in my house, and I would like to reduce my personal exposure to it, because it is so measurable. Like literally, when I have my foot half a meter away from a power adapter, I can measure the 50 hertz in my brain, in my body, and that was kind of shocking to me, how strong that is. We haven't had any questions from Carl. Carl, do you have any anything that comes up for you that has not been discussed?
I'm still sorting it out, if you can hear me. But I could use I came in a little late and I didn't pick up what you were saying about the pin you were mentioning at the very start.
VCM. In the beginning, I was going on and on about the VCM pin, which is
Yes. Well, if you could just quickly mention again what it's for,
yeah.
that would be helpful.
Yeah, I will tell you again what it's
Thank
for.
you.
Is this your first EEG stuff, or have you done EEG before with, for example, OpenBCI?
I've looked at EEG a lot, but I'm still learning it. I think it's very slow for me.
Okay, so and have you worked with OpenBCI or not? Because then I can compare it against Open. Okay. So in OpenBCI you have the bias pin, which is on one of the ear clips, and the bias is basically a way of connecting in a stable way the voltage potential of the board with the voltage potential of the body, such that they're, that they have a stable sort of reference to each other, and then from there you measure all the other positions. Here we don't have we have a slightly different thing than the bias in OpenBCI. Here it's called VCM, which stands for voltage common mode, and you connect it in the same place where you would put the bias in another position. And the bias pin is every ADC has a bias, has a VCM, and that's in this position. And considering that these blocks of pins rotate with 90 degrees every time, so it's here, and for this ADC it's here, and this ADC is here, and this ADC is here, and then the VCM pin is connected on all these four positions internally on the board. In fact, if you look closely on your board, you may even see the wire that goes around the trace. But so if you connect one of them, you don't have to connect the other ones on your headset. Just one of these VCM pins on your headset is enough. Of course, it is nice to just do them all four, but it's really not necessary. So it's comparing to OpenBCI, it is the bias, and in this case, the VCM here, it is halfway through the ground and the power supply of the board. This board runs on 3.3 volts. So the VDD is 3.3 volts, and the GND, the ground, is 0. And VCM sits right in between there, so 1.67 volts is what VCM is. So that's VCM.
So when you run that, you actually have a voltage across your head?
Yeah. So now the other thing is, it is there to reduce noise. It is my experience that even when I don't connect it, I don't see a big difference. It will make a big difference if you are in a very noisy environment, which, in any serious EEG application, that's the first thing you do. You control your environment where you're in a place where there's not a lot of noise or no noise at all. And when you do that, you will notice that the VCM doesn't make a big or doesn't make any difference, whether it's connected or not. But for completeness, you should always connect it. But if you notice that it makes a big difference, then that's a big hint for looking for a better environment. Or you might actually be, if you, for example, something you can try, if you're measuring, you're connected up to EEG, and you can, for example, just touch a battery with your finger, and you'll notice it completely disrupts your whole EEG. Now, if you're touching your laptop has a some kind of baseline voltage that it might be putting out through its keyboard, depending on the laptop. Like I've seen people where the laptop really electrifies them and completely disrupts their EEG. So that's what I mean by environment, right? Like you're in a place where your physiology, where your body is receiving noise. And the VCM mitigates that, but it would be much better to control it from the start, where the VCM doesn't have to mitigate it.
About laptop, if it near you, you experiment with laptop, better remove AC line when experiment starts.
Yes.
So even if device not connected there, even if 3G not connected to laptop, you not connected to laptop, just near, it will be noise.
Yeah, the laptop even
If-
even when it's not on the AC line, you know, just touching it will put a small voltage on your body. So you'll notice just putting your hands on the keyboard or the trackpad. The trackpad is an electronic device which has an influence on your baseline voltage. So then you're basically putting noise on your body just by touching it. Yeah, so in reply to Hermesa, yeah, you can control noise with the software filter, but I would really try to in your research to do your measurements in an environment where that is, you know, where things are noise free. That would be the first approach. And if there's no way around it, then use software filters as much as possible, indeed.
And maybe this is a good environment, as in my use case. At day, my environment noisy. At night, my AC line stable, symmetrical, I think. I not seen it, but it's filtered fine at night.
Yeah.
At day, same experiment, not work.
Yeah,
because around AC line comes from around.
Yeah, because the grid becomes noisier. If your neighbors are using the washing machine, you know, a big AC motor, it's game over until the washing machine stops.
Yeah, I'm always up at night, but I've been trying to get a house for ages, and if I just had a garden shed, this would be so much easier, but that's not happening at the moment.
You're in the UK, I think.
Yeah, not not a great housing situation right now, so lots of neighbors everywhere.
One of the people who has one of my headsets, he's in the UK, and he couldn't get a clean signal no matter what he did. And so I had him walk around the house, a laptop in hand with the EEG set on his head, while we were on screen sharing, and it was just looking horrific. And eventually we discovered when he was sitting on the stairs, halfway up the stairs, that was the only place in the house. Other than that, in the garden.
Yeah, it's his 1950 semi-detached, so designed with a nuclear fallout in mind. There's just a little bit on the stairs where you're safe from all of it.
Well, it says he was also like in an old house. It's just, you know, the electrical isolation at that time, like all the cables in the walls are not shielded and all, you know, just sort of very rickety. So yeah, I mean, literally in his house, there's not a place. He has to go outside. So you might be you might be in the same position. Hermesa is asking something very, very important. Yes, so there's a couple ways that you can experiment, which is very important. You can touch the pins, which is something you can do. Something that for me was very, very useful in my journey of learning stuff is Dimitri's method of testing the noise on the board, which is directly connecting on one or multiple channels the positive and the negative terminal with the shortest possible wire. Right? So you take a piece of copper wire and you just jump it directly from let's say on channel 1 from positive to negative. And then you will notice that channel goes completely silent. if you have the y axis on your graph on some set value. Usually,
quarter microvolt, isn't
like
it?
if you have done auto scaling, then you will continue to see noise. But then when you measure that noise peak to peak, it will be very, 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 very small. Yeah, I found that to be very useful to sort of have that as a. I learned a lot from that. little experiment. So just connecting positive to negative from one channel directly, and you'll see noise go straight down. And then when you touch that pin, there will be something, but not much of noise. And if you touch the pins which are not connected to anything, you'll see a big spike.
I sent image of 8 boards interconnected, where I tested noise with jumpers.
Oh yeah, I can see them. I don't know if it's as useful for what you're doing, Amesa, but I had the site on. They had this massive problem with these artifacts, these sort of giant noisy pulses that come along sort of sporadically but semi-regularly, a bit like a bus. Sort of, none and then 3 at the same time. And a friend of mine was nagging me to do it properly, and I haven't really got much stuff here. But I eventually did go to a lab and pick out a signal generator and just divide that down to be sort of 10 microvolts or something, and I got right to the bottom of the problem doing that, so that was quite useful. But even if you don't have access to signal generator, what you can do is just sort of have like a sine wave generation app on your phone. I mean, you can have noise or whatever, but if you just want to sort of test signal without having a headset, I just plugged an audio jack in, divided it down again, so I had something more close to what it would really be. And you can use that to get a not perfectly clean, but like good enough for just some debugging sine wave, and just plug that into the 2 positive and negative pins. I think that should give you something you can play with.
Is it safe to put audio voltages onto those?
There's sort of, I think the limit's about 100 millivolts, something like that. So possibly not, but I use resistors, so I had it hooked up to the oscilloscope just to check I wasn't going to go outside of anything you'd normally see. But yeah, you're definitely right. So like, check that first. Just hook it up and hope for the best.
I wanted to, Carl, exactly what you're suggesting. I haven't done it, but what I had in mind for a while was to create my own like a wave file using a signal generator. There's an online signal generator that just gives you a wave, and I just wanted to play that with like a high definition audio like MP3 player, and just to connect that to a channel. I haven't gotten around to do it, but the thing is, if I'm not mistaken, the volume of headphones is modulated with voltage, right?
Yeah.
So, and so the only thing I haven't done is I could do it now. At that time, I didn't have a multimeter, but I do now. I travel a lot, so at that time I didn't have my multimeter with me. But I'm still interested to use like an MP3 player and actually play an audio file, which I've created like with a known frequency. Like not something that you would ever hear. Like basically, I would take an alpha wave and lay like a beta wave over it, and just play that as an audio file and measure that. That's something I still want to do sometime.
The problem you might find is because audio frequencies, anything below 20 hertz, very few people can hear, and 50 hertz is about the level people mostly start getting into music. So you could find some of these devices are sort of like, I'm doing quite a lot with relatively slow waves, sort of 1 hertz area is what I'm training at the moment. So that would quite possibly definitely be out with the range of a lot of MP3 players and stuff like that. Annoyingly, but definitely. I just went to like the Google Play Store, sort of looked up tone generator or something. I may even had one on there already, and you can just dial it around, and it was very much good enough just for the time being. Because the artifact problem turned out to be impedance actually, which is something I'd written down. I'd forgotten to ask. I don't know, Dimitri, if you know what sort of maximum input impedance on the electrodes would be to get a reasonably good signal, but as from what I've seen, like I don't know, 50 kiloohms or something is not great, but sort of within tolerance. But the Titan certainly packed out beyond sort of 15 or 20. It was just these pulses were all that was there. So that turned out to be what the issue was.
Maximum impedance depends on your noise. If you have
Okay.
no noise, you can use electrodes, capacitive electrodes. They're capacitive electrodes with highest impedance. They just have no connection between electrode and head, just via air.
Yeah.
So with insulator. So what it only works in laboratory environment when you filtered everything. So no noise at all. Then you have capacitive electrodes. Other impedance will just acquire noise. It's just antennas, many antennas, 32 antennas or more. They have noise from this impedance. So better to use just gel electrodes with all gold connectors. All connectors need to be gold. Non-gold will add impedance. Less connectors, more soldering. Solder everything, or gold connectors.
Yeah.
And to head, also I using poga pins with gold, and also adding gel. So poga pin with the springy part connected to head, it's not no pain, and this is it's connection of gold to skin, and also gel. So it's not dry electrode, but with gel. And I placed these electrodes, or not. So electrodes better if you use an electrode with just gel without connection of gold, it will give additional impedance.
Yeah.
Not big, but more. It will create more restriction on which noise you can have in your environment. More impedance, you need to have less noise for the same algorithm.
Okay. So when you're doing the pogo pins, you're always using gel then? Because I thought those work dry, but
when you acquire data to teach algorithm, you need gel electrodes better to have. When you have teach algorithm which learn everything, then you can have filters, this algorithm, and you can have dry electrodes. I think okay, but for better data for learning, better have gel electrodes. It's just my hypothesis.
Okay. Yeah, I mean, it obviously gets you a better signal. It's a pain in the ass is the main thing. Like, I'd love to have a hat that you could just sort of put on and take off, and even if it's sort of like good enough data. If I get good enough data out of something, that just means I'm trying to apply this all to myself, and I've only got 2 arms, and it starts to get pretty tricky after a while trying to juggle the electrodes and the gel, and then an elastic band type thing, and then I've got to sort of keep it on for ages to redo it. Yeah, I'll give it a C. Mine are all silver rather than gold, but I think that should be pretty good as well. I'm following some stuff from a paper, so I'm sure I haven't done it as well.
Silver has less impedance than gold, but silver tarnishes and corrodes. So as long as you keep them clean, you'll be better than gold. But when they're not clean, then that's the thing. Gold is actually not a very good conductor, but it doesn't corrode. That's sort of its only good quality. It doesn't easily corrode.
On GTEC site, the information that they're using gold for more than 0.5 Hertz. For more than 0.5 Hertz, gold is okay. For less, need silver chloride.
Silver chloride. That's
EEG
which
is more than one.
Yeah, but there's a difference between silver and silver chloride. Like you can.
I mean, no, yes, silver chloride is the best. Is the standard. Gold standard, silver standard. Silver chloride.
Silver chloride standard.
Yes, for zero Hertz. But for EEG, it's okay. For more than 0.5 Hertz, it's okay for gold. It's on GTEC website.
Great. Does anyone else have any other questions or remarks? Maybe we should do like a weekly connect for anyone who's got questions.
Yeah, that'd be quite nice.
For a little while to come. All right, let's see. To recap,
maybe when people will have connected devices, can share screen with their data, and we can check setup.
I think doing the multi-board setup will need a little more still, like at least one more session. But the single board pinouts for any headset, I think we've thoroughly covered that.
Yes, I think more than enough. More than enough.
I mean, we can.
Without going into all of the here be dragons about the exact electrical workings of differential amplifiers, which I'm sure Dimitri would be able to talk about for many hours, but my brain might see a massive spikes as it overloads at that point, trying to take it all in. But
yeah, let's think about. Right now, I cannot give an exact date. Coming 2 weeks are very much on the go for me. Yeah, I think Ermesa, if you start with experimenting just with a single board and touching the pins and sort of getting familiar with all of that, then slowly you'll get ready to connect the big headset with 64 and to interconnect those boards. So I think you have enough homework for the moment. Carl, do you have enough homework for the moment?
I haven't seen a board yet. I ordered a headset. I think Bernard actually built the headset, I heard.
Okay, yeah. So then you're depending on me, and then this whole story was irrelevant for you because everything will be connected. Yeah, so did you order a 19 or just a 2-channel headset, or the combination of 19 and 2-channel?
I probably ordered the big one.
Yeah, so the 19. Well, the big one, like the biggest possible set.
I'd have to go and check.
Either way, yeah. So for you, when you get your, so I'm making those headsets. And a couple days ago, I got abruptly called away, and that's why I'm sort of like on the move right now. But I'm halfway producing the things, and as soon as I finish them, I'll send them to Josh, and he'll send them to. There's a convoluted path there. I have to send them to Josh. Josh will send them to Crowd Supply, and they'll send them to you. So as far as I know, that's how it will go. But yeah, so for you it's actually irrelevant which the pins are, because you just connect the headset and then it's all connected. So that's the story there. And
I'm
with
still interested.
connecting the headset, like it just pairs and you tighten it and that's it.
Can you swap out your own electrode?
Yeah, so I've made a system where you where it's modular. So the amplifier will have spring-loaded pins on it. So on the pinout that we have here on the screen will have, well, the whole thing will be encased in a housing. So unless you open it up, you're not going to see the board. And there will be spring-loaded pins on here. I'll send you a link. Send everyone a link with the kind of the let me see. All right, so I'm sending. Yeah, I just sent a photo, a photo album on the channel, a Google Drive photo album, and that shows sort of the headset and its development while I was working on it. You're going to get a newer version of all of this. You can swap out from the 19-channel set to a 2-channel headset. And I'm working at the moment on a 32-channel headset. And instead of the in these pictures you see these white strips that go from position to position. That's the previous design. You'll get wires, and those wires are much more durable than the white strips. So that's on its way. You know, it will take me a few weeks, but then it will be on its way. I'm already halfway with the soldering and everything. So that's what's coming to you.
Sounds exciting.
And I made a video actually. Made a little video that shows it more in detail, which I will link. So here's more in detail how the headset works.
They from Crowd Supply. I scraped the links so I could possibly paste them all up.
Oh, the video was already on the Crowd Supply?
I think that one. Yeah, I think that one was in the update.
So I'm just sending also another link with the 2-channel headband demonstration that shows you how you can swap out headsets.
I'll try to get all this typed up at some point. It may take a couple of weeks, but well, not all of it, because that'll take me forever. But I'll try to get some of the basics and some diagrams and stuff, and then if there's some way I might do a pull request or something on Git, and then you can double check if I've made mistakes or things are inaccurate or whatever, but can edit it from there if you want.
Oh, cool! Yeah, definitely.
Maybe you could even just wondering if it's worth consolidating some of it in Markdown or something, so then it could just be dumped on the website or something using I don't know if you want to use GitHub Pages, or if I don't know where the new IDSS sort of main site is back from, but we could do it in such a way it could be rendered as HTML easily, or some point make it a bit more official.
Yeah. yeah, that's kind of where we need to go. Anyway, I think that this might be a good conclusion of our session. And let's within a week or two, probably two, connect again and see where everyone is at. And there's probably also a lot more people at that time who have their boards and who will have more questions.
Yeah, that sounds great. Thanks so much for doing this. I really appreciate it.
Yeah, thanks for being part of this community and being a very proactive part of it.
Yeah, it's I don't know. For me, it's what I've been in and out of therapy my whole life, tried everything. It doesn't work. This is, if this does something, and it is. I've felt it a couple of times. I'm just trying to work out at this point what I don't know what the variables are that determine whether a feedback session does something or just doesn't seem to do much. But it's I don't know. I kind of got a lot riding on it for personal reasons. So I'm very much like this works. I could see myself taking this as my career. So
yeah. Recently I started applying all of this stuff also for neurofeedback, and I'm in contact now with the neurofeedback clinic. So I send them recorded data, 19 channel recorded data, and then they run it through all of their stuff, and they charge $200 for it, like $190. And they give a very detailed report and recommendations of all the things to train and like specific positions. So you might be interested in that as well.
Yeah, I think I guess a lot of the analysis depends quite heavily on what system they're using, because the sort of proprietary software spits out what is been framed in those terms. But I think there's a lot of interesting stuff looks like coming out on things more like coherence and be that in phase, be it in frequency, be it what have you. The fact that low frequency is sort of associated with lower energy states and high frequency with high energy states sort of it's really nice parallel with the way photons work, whatever, so that makes sense. But part of me is not so keen on sort of, I don't know, tuning every dial and thing back here and there. A bit like you're tuning a piano. I feel like there's got to be a way out. There's a bit more just like giving the brain a good big jiggle and letting it find itself. Sort of, I'm kind of betting on multiple channels and sort of looking at something that kind of unites between everything and just lets it replasticize rather than sort of trying to fine tune it too much. But we'll see. That's just a hunch. May not be empirical.
Yeah, no, it's I think there's a lot of possibility for gaining good stuff with all of this. Oh, Hermes, I see that your teacher might want to have 20 boards. We can. That is almost possible again now with the chip shortage. And I will be producing more boards as soon as possible, not through crowd supply, but privately. So we can talk about that. All right, let's call it a day. That was great, everyone, and we'll just stay in touch on the channel, on the EEG channel, on the Brains at Play.
Yeah, thanks again.
I'll put this thing on YouTube.
Yeah, I'll drop a line when I've written stuff up and send you a link to whatever.
Yeah. All right, great.
And idea maybe to make some workshop for your coherence neurofeedback. Maybe someone will be interested who will have devices how to set up your coherence neurofeedback.
Yeah. I think that is like the next step. Maybe not the next one, but the one after that, when everyone is capable of reading EEG. But for sure, I think we should make like a weekly workshop, because like soon there will be many more people, and we have so many interesting things to do, and the coherence is already there. So yeah, Dimitri, I think we should, you know, we'll build a little community here, and get everyone's sort of, you know, incorporate everyone's input. And
I think, I mean, there's the information is out there on a lot of this, but it's quite hard to find and pour through. And I guess kind of the research angle is slightly different. If you look at a neurofeedback angle, for example, like a lot of there's a big difference between designing a system and say a therapist who uses it, who's much more, you know, following an instruction manual and things like that. So like for me, just trying to find what parameters might affect a protocol, e.g. latency is a thing that comes up.
yeah,
It you know, the basic things of, okay, you're tuning this site and that site and this frequency is very different from how do I go and do that in code and get it right. And, you know, with it all being proprietary, it's took a lot of searching to sort of find some source code or some designer files or whatever that I could at least base it off, but, you know, without just very basic, okay, do a fast Fourier and look at the band power. So it can take a while to like accumulate the knowledge of how to do all this stuff, because it's not so easy to find through Google in one go.
no, it's not. Let's when I resurface, I'll let you guys know on this channel, on the EEG channel, and then we can have the next session.
Sounds good.
Great. All right, everyone. Thank you for joining.
Thanks,
That was
Ken.
fun.
I'll see you around.
That was a lot of fun. Yes. See you guys.
Cheers. Have a good one.
Thank you.
Bye.